Welcome to the Video Laboratory series presented by Thinking Out of the Beaker. Today we're going to take a look at an activity called paper bridges. In paper bridges we're going to build 4 bridge structures using index cards. And we're going to change some design element in each one of those bridges to see what effect that has on the ability of the bridge to withstand a load. Let's just take a quick look at the materials and the type of bridges that you're going to build with this little video clip. So let's just take a look at the materials we'll be using. We're going to use pennies as a load, and each penny then will count to see how many pennies the bridge can hold. Markers or pencils, if you have them, are going to be the bridge supports on either end. You need a ruler, some scissors, and a pencil, along with some index cards in order to make the various bridges. So our first setup will just simply be one index card suspended between the 2 supports. The second setup is that index card cut in 3 pieces and then suspended between the 2 supports. The third setup will be that same 3 pieces, but we'll glue them together to laminate them into a beam, and that'll be put in between the supports. And then finally, we'll take one index card and we'll fold it into a beam shape and suspend that between the 2 bridge supports. Now that you've had a chance to see what materials we're going to use and how we're going to build each one of the bridges, we want you to try and answer this question then. How do design changes affect a load-bearing structure? Now remember, you have 4 choices. You have the single card suspended between the 2 markers. You have that same card cut into 3 pieces and then stacked on top of one another. You can have those 3 pieces then glued together and laminated into a beam. And the final choice is a single card, but it's been folded into a channel shape. So just take a moment now with your group members and decide on which one of those 4 shapes of bridges you think will be best at holding a load, or in this case, hold the most pennies, and then make your prediction on which one of those you think is going to be best. And once you've made your prediction, come up with an explanation with your group members as to why you picked that particular bridge. When you've done that, we'll start the video again, and you can actually have a look at the testing and see which bridge actually does hold the most pennies. So this is our first test then, back to a single index card. So we'll place one index card across the 2 markers, and then we're going to use pennies, remember, as our counter. So let's start adding those pennies, and we'll add them one at a time. So we have 1 penny, 2 pennies, 3 pennies, and the cards touch the table, so we'll say that this bridge was able to hold 3 pennies. Our second setup, we took the card and cut it into 3 pieces, so just 1 card but cut into 3 pieces. We'll place those across the markers, and again we'll add the pennies to the top of the bridge one at a time. And here we go, 1, 2, and 3. And again, the bridge is touched down, so we're going to say only 3 pennies again for the bridge with 3 pieces. Third bridge is 3 pieces again, but this time we've glued them or laminated them together. And we'll place that bridge across the markers and add pennies again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we get 10 pennies piled across on the bridge this time before it fails. The final bridge, we didn't glue it this time, but all we did was take the card and fold it into a channel. So fold up the 2 sides, and we'll place that across the markers. And then we will load the pennies in again. I'm going to cheat a little bit though. I'm going to load the pennies by stacks of 10. So that's 10 pennies starting on the bridge. And we'll add another stack of 10. So that's 20. 30. 40. 50 pennies stacked in the middle of the bridge. 60. And the bridge is still holding, no sign of bending or changing shape. Let's try a little bit more. 70 pennies on top of the bridge. and it's just become too unstable to be able to stack the pennies. So we'll say in excess of 70 pennies. So let's just go over our results then and have a look at what we just found out. So with the single card, we were able to hold 3 pennies. By cutting the card into 3 pieces, but then not gluing them together, we again held 3 pennies. 3 pieces, but laminating them, so gluing the 3 pieces together, changed the load-bearing ability of the bridge, and we were able to hold up to 10 pennies. And then finally, the best overall was the single card and folded into a channel shape. And that in excess, before our load just spilled over the edges, was 60 pennies. So you can see very clearly that changes in the way that we arrange those materials do provide a greater ability for that bridge to hold on to a load.